Okay, so we're gonna now give a very fast overview on how to do part 5. I'm not gonna explain it too much into detail because it's very similar to part 4, and this is when you're just gonna use the skills you've learned to solve this last part. But I'm just gonna tell you basically what we're expecting from you. So all of your initial conditions, so they're going to be a little different initial conditions, are given, and then your new gamma is given. So for the first part of part 5, what they ask you to do is, okay, set gamma to the new value, give me your new initial conditions, and now solve for one step. So basically we want to do exactly the same thing we did for part 2 when we solve for one step. So again, write down your ODE the same way you did for part 2, and then plot it. That's all you have to do for this first line of part 5. Same thing, just now your ODE with your new conditions. The same thing for the OPT, you're still using the one with the event. The only OPT that doesn't have the event is the very first part of this project. After that, all of them have to have that event that we created before with the striker function. Now you can go ahead and plot it, and it should look very similar as the one step that we did before. Now what they want you to do is to create a y minus, which is what they're saying here. So then use the solution to find y plus. Remember that to find y plus, you need to find y minus, which is, again, as we've said a million times, is y and comma, colon, and then don't forget the apostrophe again. Then calculate your C, then calculate your A. So basically the same thing we've done before. Then we're going to have y minus equals what you know y minus is. Then you're going to have C, which equals what you know what that is. Then you're going to have A, which we already know what it is. And then next thing you're going to have is the only thing that's kind of different, which is you're going to find the difference. And you're going to find the difference between your initial conditions and then your y plus. So after A, find your y plus, which we already know again how to do. Is just the equation 5 here, which y plus is equal to A times y minus. So just find your y plus, and then the difference that they want you to look at is equal to y naught minus your y plus. And then look at those numbers and then compare them to 10 times 10 to a negative 3. So then with these values you can analyze whether this is a stable or an unstable dynamic, and then I'll leave you up to you to figure that out. Now for the next part, when they ask you to do 20 steps, it's going to be almost the exact same things. Basically, for the most part, you can copy and paste what you did for part 4. Again, we're going to start outside of the loop with our empty vectors. So you're going to do that for t, for tau, and for y. Same thing as part 4. You're going to have those 3 empty vectors. Then you're going to have again your t naught equals to 0, and then inside the for loop is almost the exact same thing. So the first thing you should have is your ordinary differential equations with t and y that have names that are different to t and y, because you're going to use the t and y variables to save after each step. Then you're going to find your tau, same thing you found tau for the step before, and then you're going to find your y minus, your C, your A, then your y naught, then your t naught. Basically almost the exact same thing that you had for your previous part. Then you're going to end that loop, and again we want you to output the period. So basically just output tau. Now plot it again how we've plotted everything else, and then just see how that differs from what you plotted before. Basically there's nothing much different. Basically you're repeating the same thing you did for part 3. It's now just steeper and you have more steps. That's all you have to do. Again, feel free to message me if you have questions. What I've seen a lot of mistakes have been forgetting to add that T naught in your here in your time step, because you want every step to begin at the end of the previous step. I've seen errors in calculating tau I. Remember that they all should be 3.9, 3.8, 3 point, numbers like this. If they are different like that, then you're calculating it wrong. Then don't forget to accumulate your solutions. So this is just how we accumulated T, but don't forget to do it for Y as well. And I think that's all you need to know. So good luck on the project, and I'll see you guys for the next project.